Hi everyone, welcome to the basics of hardware with the PyRuler. My name is Kira Hartlage and I'll be talking to you today about a little bit about hardware as well as how to get started using Python. Hi, my name is Kira Hartlage. I have a background in mechanical engineering and consumer appliance design at GE Appliances, located in Louisville, Kentucky. I started my software journey teaching myself Python using edX, Coursera, and various other online courses before branching out and switching to embedded development at my current company where I now write code for microcontrollers, which I primarily write in C for our consumer appliances. Here are our desired outcomes for our time together. I'll introduce you to a bit about embedded firmware development. I'll introduce how you can use CircuitPython as an alternative to C, which is the most common software language used for writing embedded software. We'll also look at an example of how to write code for hardware using the PyRuler, and then I'll show you some more resources and examples of projects that you can explore to learn more on your own. Embedded software development is basically writing code to control a device that is not a computer. So you typically don't have an operating system, and you'll be dealing with memory and time constraints for that particular device that you're writing code for. Embedded software can also be called firmware, as firmware is stored in non-volatile memory, such as ROM, flash, or EEPROM. In the past, you would not be able to update the device's non-volatile memory, hence it was referred to as firm. But nowadays, there are methods to update non-volatile memory without too much of a headache. So now we typically refer to it as embedded software. Central to many hardware applications is the microcontroller. It is an integrated circuit with a processor, memory, and various input-output peripherals. Microcontrollers are designed for embedded systems, whereas microprocessors are used in personal computers and other general-purpose applications. And then the peripherals are the various parts of that microcontroller that interface with the outside world. So what are microcontrollers? They have three main pieces. They have instructions, which is what the microcontroller is capable of doing, registers, which are special fast storage locations in memory that the microcontroller has access to that the instructions can use, and then various other types of memory, which can be used to store your code and data, but they're usually slower for the microcontroller to access than it is for it to access the registers. Some examples of peripherals are GPIOs, general purpose input-output. Example of this would be reading a binary sensor input or lighting an LED. An ADC, analog to digital control. An example of this is reading a thermistor for a room temperature and converting an analog count to a meaningful temperature value. A PWM, which is also known as pulse width modulation, which can be seen as a square wave. An example of this would be controlling a variable speed motor with a varying frequency or duty cycle in that square wave. And UART is an example of a serial communication peripheral known as Universal Asynchronous Receiver Transmitter, and that's one of the various communication ways to communicate between two devices, such as a microcontroller to a microcontroller or sensor to microcontroller. Commonly, C is the language of choice for writing code for microcontrollers. C is compiled, low-level language that plays nicely with low-level hardware needs, as it can be very small and size inefficient. It's small in terms of memory because it doesn't rely on as many libraries as higher-level languages do. And microcontrollers are very memory constrained. C is a bit more difficult to learn than other languages, and it can be difficult to get a microcontroller started up from scratch. But if you're looking to get into hardware, thankfully, Adafruit has created a derivative of MicroPython known as CircuitPython. CircuitPython is specifically created to educate people on how to program microcontrollers and get it up and going as quickly as possible. What's really nice about this is that there are many low-cost microcontroller boards available, and CircuitPython also doesn't need any special desktop software in order to get started. You can use any text editor to start editing code, and you don't need to install a fancy compiler or need special equipment to upload the code either to the board. A lot of the microcontroller boards available from Adafruit already have CircuitPython on them, so you're ready to go. And since CircuitPython is based on Python, it's also easy to transition and learn and get started even if you don't have any prior programming experience too. Here we have the PyRuler. In its most simplest form, it is actually a ruler. It's also a reference board that shows you what various PCB components look like, and a PCB is a printed circuit board. It shows you what the components look like, what their size is, their names, so you can use it for reference when you're designing a board. But it also has a few cool features that makes it a simple board to get started with in your CircuitPython journey. It has a Trinket M0, which is a Cortex M0 microcontroller, which is shown in the yellow circle. It also has 4 capacitive touchpads with matching LEDs, which are the gold-looking buttons with an LED above them. It also comes with code already loaded on it, so all you need to do is plug and play via the USB. Each of the 3 capacitive touch buttons will type that Greek symbol as keyboard input on your computer. and then the DigiKey button sends you to their website. Because the code's already on the PyRuler, it makes it easy to edit and update right away. All you need to do is save it, and the code is loaded to the board. Hi everyone, now I'm going to show an example with the PyRuler. It comes with code already on it in a code.py file, which I am modifying in VS Code to change the behavior of the cap touch buttons. Here in the while loop at the bottom, while true, this is the main execution loop of the file. If you press one of these cap buttons, it'll do something different. I changed it to do Control P or go to file for the first button. So you can see that pops up. You can search for a file. I changed the second one to do the show command palette, which is Control Shift P for me. And then this third one, I did just to find the search command. It's finding that. That's what I clicked on last time. And then the third key, or sorry, fourth actual cap touch button, prints, looks good to me. You can see that printing in the terminal at the bottom, which is what we put on our pull requests when they look good. Yeah, the existing code printed different things, but I just kind of shifted around to do different shortcuts in VS Code. I've seen other examples. Change it to unmute or mute, or turn your camera off, turn your camera on in Zoom or Microsoft Teams. It's another easy example to get started with. There's lots of libraries that Adafruit has that you can just import and go to town. Just get started going, changing what these outputs are. There are other intro boards available from Adafruit with CircuitPython on them. Two that I wanted to highlight are the Circuit Playground Express and the Circuit Playground Bluefruit. They both look the same as that picture in the right. The difference is that the Bluefruit has Bluetooth connectivity, where you can connect wirelessly with it using Bluetooth, and there's also an app on the phone that you can use that Adafruit made to interact, which is really cool. These boards are really helpful because you don't need to worry about wiring up your own sensors and worrying about the whole circuit analysis and how to get that going. They come with various sensors, some of them listed here, so you can use those to get started on your next project. One of the really cool things about CircuitPython is that Adafruit has created a lot of libraries that make it very easy to use and get started. Here's an example with the Circuit Playground Bluefruit. First, I'm importing the Circuit Playground library and also importing time. Then I'm setting the brightness of the pixels to 0.1, which is low. It's between 0 and 1. They were very bright initially, so I set it down. Then in my while true loop, I'm doing the following. So it checks if button A is pressed. If it's pressed, it plays this radio tune. If button B is pressed, it will play a punch sound. And then if this detects a sound using the sound sensor above this threshold of 250, I'm not sure the actual units of that, but it's nice they're able to change that. It'll fill the pixels with a different color for these lights. So this is RGB 50, 0, 50 for red, and blue is 50. Then it'll sleep for 0.2 seconds. If it doesn't detect a sound above that level, then it will fill the lights with 0, 0, 0, which is basically no light. It'll turn them off. This bottom part is setting the red LED to either on or off based on the switch position of a closed or open. And here's a video of me tapping it on the table to make a sound in order to light up the LEDs, and then I'm pressing the buttons to play the different sounds. I'm trying to make a loud sound. So the code I showed with some more code examples, the transcription of the slides, roughly the same as what I said, and then some more links can be found in my GitHub repo, linked below. It's also in the speaker description on PyOhio's website for the link, as well as I want to highlight the Adafruit. They have a Learn site with a lot of great learning resources as well, and also people post their DIY projects. You can see what other people are making there. Check it out. Thanks everyone. You can contact me at kira.hartlage@gmail.com with any questions. You can also check out my repo on GitHub. My GitHub handle is Kira. Thanks again.